Assalamu alaikum. Today the lecture is about quadratic equation and define how to solve a given quadratic equation by using factorization or completing square. Basically, quadratic equations can be solved by three methods. First method is by using factorization, that is using factorization. Second method is completing square. Completing square. And the third method is by using quadratic formula. Quadratic formula. So these are basically three methods to find the solution or given roots of quadratic equation. So first we have to deal with the factorization, what the factorization is and how to solve using factorization, then completing square, and later on with quadratic formula. This will be the general preface of this chapter. So for quadratic equation, generally, what is a quadratic equation? So quadratic equation is an equation having degree of variable degree of variable equals to 2. So the highest degree of variable equals to 2. So for example, a general equation is ax square plus bx plus c equals to 0. So this is basically a definition of quadratic equation. So an equation in which contains the square of an unknown variable, and basically square is the power of the unknown variable. So in this equation, the unknown variable is x. So x having the highest power equals to 2. So this is the quadratic equation. Now we have to solve this by using factorization and given formula. So first is by using factorization. So for how to solve a given using factorization. So for a factorization, we have equation that ax square plus bx plus c equals to 0. Here there are two unknown two numbers that I am taking r and s are the two numbers for this equation. That is equation number 1. This is my equation number 1. So this means that r plus x equals to b. This r plus x equals to b, or sometimes r plus s equals to b. So generally there must be a r plus s equals to b. This unknown variables. How to find this unknown? Because this is basically is the midterm breaking of b. So we have to split this b into two unknown variables, that is r plus 5 or s. So for b, for example, equals to 6x. So we have to know that 3x plus 3x equals to 6x. So the r is 3x and s is also 3x. So basically this is the splitting of variable x coefficient, that is b. Now for the second equation, the rs multiple, that is r, when r and s multiply, both must be equals to the this multiple, that a multiplied by c. So the when we multiply this unknown value that we computed in the b, the multiplication must be equals to the factor, that is a multiplied by c. So this is the general elaboration of how a factorization solve using a simplification method. So this is basically is the general rules for factorization. Now we have to solve a given problem. So for example, a problem is given that 3x square minus 6x equals to x minus x plus 20. Now 3x square minus 6x, then this is positive, then this is equation sign, that when this equation, this x is gone here, so sign must be converted into negative, and also this is also converted into negative. This must be 3x square minus 7x minus 20 equals to 0. So this is basically is the standard equation that ax square. This is basically the form of ax square. This is basically form of ax square plus bx plus c equals to 0. Here the a value is 3, b value is minus 7, and c equals to minus 20. So for the general, we have to split this 7x into two variables. So how to do it? That is 7x must be split into two variables, that the sum equals to 7x, and when we multiply these two variables, unknown variables, it must be equals to 30 multiplied by minus 3 multiplied by minus 20 equals to minus 60. So 7x must be equals to 7x. So how to split it? The first is, when we there must be negative sign. When we minus 12 with 5, that is when we subtract 12x with 5x. The answer is 5x, but there is a negative sign, that must be negative. So there is a negative sign with 12, the bigger quantity. So minus 12x plus 5x equals to minus, and the 2 1 12 into 5, that must be equals to minus 60x. So these are basically two unknown factors of minus 7x. So it must be separated into 3x square minus 12x plus 5x minus 20 equals to 0. So here we take common 3x, x minus 4, then taking 5 as a common, then x minus 4 equals to 0. Now the first vector must be x minus 4, and the second is the 3x plus 5 equals to 0. Now, now there must be, first is x minus 4 equals to 0. So the value of x equals to 4. And the second is 3x plus 5 equals to 0. So this means that 3x equals to minus 5 and x equals to minus 5 upon 3. So these are basically two roots of x, that x equals to 4 and the value of x equals to minus 5 upon 3. So these are basically two unknown values that we find the root of a given equation, that 3x square minus 6x, sorry, 3x square minus 7x minus 20 equals to 0. So this is basically is the factorization part. Now we will move towards the second part, that is the by using completing square. So how to complete a square? So for completing a square, for example, the equation given is x square. That's one. It is x square minus 3x minus 4 equals to 0. So first you have to take this constant, that there is always a value of c constant. So you take this constant here at right hand side. So it must be x square minus 3x equals to 4. This is the first step. Step number 1, to take this constant from left hand side to right hand side. Now the second basically is the adding the square of 1 by 2 into the coefficient of x. How to adding the coefficient? Now add the coefficient, that is this is 3. The coefficient of x is minus 3. The man processes this one. Now the coefficient of x is minus 3, and then you have to multiply with half. This is the standard. This value will change, but this is the constant value, that 1 by 2 is add to every value that is the coefficient of x. So again I am saying that multiply half with the coefficient of x. So coefficient of x is minus 3. So minus 3 equals to, this equals to minus 3 upon 2. So this value equals to minus 3 upon 2, minus 3 upon 2. So taking square, so this square will be, now second step is taking square of it. So taking square of it means that its value equals to minus 3 upon 2 whole square. Now this is basically the most important part of this, of the completing square, to how to find the value of the multiple, that is first. So then you have to sum this value at both sides. So it must be x square minus 3x. Then this is basically is minus 3 upon 2 whole square equals to 4 plus minus 3 upon 2 whole square. So this must be a square. This must be a square plus b square, that is negative of this one, minus 2. For example, this value is positive, so 2a value is x and the b value is minus 3 upon 2. So this 2 will cancel out with this 2, and the answer must be minus 3x. This is the verification. So this is basically a square minus b square formula, and this will just simplify it. 4 into 3 square, that is 9 upon 4, and this is a minus b whole square. So after the taking LCM, this value equals to 25 upon 2. So this is basically is the value, that is x minus 3 upon 2 whole square equals to 25 upon 4. Now taking under root on both sides. So this value must be equals to plus minus under root 25 upon 4, and it must be under root whole under root will cancel out this one. So the value is nothing but is equals to x minus 3 upon 2 equals to plus minus. This is basically the multiple of 5, so it must be 5 upon 2. For the two roots having value equals to, first having the value equals to x minus 3 upon 2 equals to plus 5 upon 2. So this must be equals to x equals to 5 upon 2 plus 3 upon 2. So this value equals to 8 upon 2, x equals to 4. In the second, the value equals to x minus 3 upon 2, and the second is the minus value minus 5 upon 2. So this must be equal to x equals to minus 5 upon 2 plus 3 upon 2. This will make minus 2 upon 2, and the answer must be minus 1. So this is basically our the root. One is minus 1 and the second is the x equals to 4. So this is the method to solve using uh, completing scale. So this is the introduction of how to solve a quadratic equation using factorization method and the completing scale method. So this is the basically is the end of today's lecture. In the next lecture, I will start exercise number 1.1.